That's what we want to do. Excellent. Oh my gosh. I hope it's actually, yeah, it should be. I think the mic's on. Anyway, okay. So we have already entered, this is our difference in means, right? And so we're learning a couple things right now. We're going to learn how to do a performance curve, how to do a graph, right? And then a couple other things. Okay. So first of all, we input all of our data for the whole class. Now you guys are only going to do the data for your group. So notice down here that I have multiple tabs, right? So this is the raw data for everybody. I made a tab for your data only, set up the same way, right? So you're going to put in your sunshade. Yeah. Okay. All right. So let me just real quick go back to this. So I'm going to do this. I will share this document with you shortly. Okay. So for now, I'm just going to do the whole class data. Okay. But you guys are going to be doing this on your own for just your data. Okay. So here's how we do a performance curve. So what did we say a performance curve was again? Remind me.
If our sample sizes are enough.
That's what it does, but what is it? That's what we use it for, but what is it? Running mean, yeah? Oh my God, my facial expressions are horrible. This is bad. This is bad. You guys are going to watch this and you're going to be like, that's true. It is. It's bad. No, am I that vain? Am I? Maybe I might be. Okay. So where were we? All right. So we haven't talked about this yet. So we did talk about how to sum, right? So let's talk about how to do a mean. Well, Excel isn't cool enough to call it a mean. They call it an average. So whatever. I'm going to actually make this a little bigger. Well, I can't do it when I'm in this screen, but hold on. So the way you do an average is you type equals average, open your parentheses, and then you can either click on, right? Or you can type in B3, because see how that cell is B3. Okay. Now for the first thing, I just want to know the average of that one. So just like our sum, we put a colon. So I only want the average of this single cell to start with, because that we're assuming that like we've collected all of these different samples. And so our mean of one thing is that one thing, because it's that number divided by 1. Yes. Cool. Okay. Now you got me. So then I got to close my parentheses and then I hit enter. And unsurprisingly, now I want to zoom in so that you can see a little bit better. I'm gonna on the video. There we go. That's better. Okay, I zoomed in. All right. So yes. So I did the average of just that first one. Okay. Now the second one, what do I want to do? Right. Amber's like a boss. Okay. All right. So I do average. Yeah. Now I want it to be for this one. And then I do colon, because now I want it to be the average of the first two. Yeah.
We have to type one.
Yes. Okay. So then, yeah. So now I'm doing the average of B3 and B4. Yes. I hit enter. Okay. Now I'm actually going to go back to this one and I'm going to do something weird to it, because if I just do that, it's not going to work. So essentially, remember, you have to tell Excel what you want it to do. And the only time Excel makes a mistake is when it's not that Excel made a mistake, it's that you didn't tell it what to do correctly. So you did it wrong, not Excel did it wrong. Okay. So we're going to avoid we're going to avoid telling Excel the wrong thing. And here's how we're going to do it. So far, so good, right? The numbers, it tracks, it makes sense, right? So 1.93 is the mean of 1.93. 1.94 is the mean of 1.93 and 1.95. Yes. Okay. So I'm going to go back up here. This is where my equation lives. Okay. And I'm going to add a little something here. And what I'm going to add is I'm going to add a $sign before, oh wait, not there. My bad. I'm going to add a $sign before the first column and a $sign before the first row. Okay. And the reason I'm doing that is essentially what that does is it says, if I'm copying this equation into other cells, it like freezes that one in place. Okay. So really quickly, I'm going to do it up here too. Okay, so dollar signs freeze your starting point essentially. Okay, so you got to put one before the column and one before the row. Okay, beautiful. All right, then what you can do is you can just, remember how we did this before with the sums? You just grab that little, you just click on that little square on the corner and you just drag it down. And we're going to cross our gonads. That it does it for us.
Oh, so do we necessarily have to do the first one or just from the second one on? We do.
You don't, well, yeah, because you want it to start in the same place. So then a good practice to be in is to always double check and make sure. So I'm just going to kind of go through a few of these and just making sure. Yep, if I look at my equation bar, they're all starting at B3 and it's doing exactly what I asked it to do, right? So I always check just to make sure. So that, yes, it should be. If you forget your dollar signs, what it'll do is it'll do something weird where it only does the 2 at a time, not all the way back to the beginning. And we don't want that, right? We want it all the way from the beginning, all the way. Okay. So when we get to our last one, notice it's the average of the very first data point all the way down to 62. Yeah. Okay. Beautiful. Now, guess what? What do you think I'm going to do to get the shade data? Oh, watch this. Watch this. I'm going to go like that. Okay. But now, oh, wait, but we got to change the dollar signs to, right? Because now it was saying, now what it has me doing is it has me doing an average of this and this. Yeah. So I don't want it to do that. Right. So what I'm going to do is I'm going to change this to C because I want it to only be doing the average of C3 to C3. Right. You with me? Hit enter. Okay. Is this the average of C3 to C3? Okay. So then I'm going to grab my little square.
You already put in the dollars.
I did. I just copied it over. Okay. Let's see. See if it works. So that goes from C3 to C4, C3 to C5. Yeah. That took 30 seconds to do. Once you know how to do it and you remember your dollar signs, and then you should always check because, right? So I like having the little dividing lines between, because I'm like a little bit extra with this stuff. I like having the little boundary lines between the different groups just so that I can kind of keep track. So I'm going to put those in because otherwise it bothers me if they're not there. Because, you know, I'm a little special that way. Okay. Now, let me zoom back out. I'm going to show you, there's some other stuff down here. Actually, let's look at this and then we'll go back and look at the graph. Okay. So what is this? So another thing I want for you all to do today. So another thing I want you to do today, I can talk, is I want just some basic stats that Excel does easily. Okay. And I actually already programmed these into here so that they should just populate for you. You shouldn't have to remember them, but if you need to, like if something happens and they disappear, you can always look up what the equation was here. Okay. So min, max, what do those tell us? That tells us what's the smallest number in this column, what's the largest number in this column. So it's just reporting of that collected, right? Of that pile of data from B3 to B62, right? What is the smallest number? What is the biggest number? What is the range? What does range mean? Max minus min, right? So that kind of tells us like how much of a difference there is between max and min. Oh, look, there's our mean. Hey. Yeah. Now, what's the, oh God. Okay. What is median and mode mean again? We know what mean is. So median is, so it's the middle value, right? Okay. What's the mode? The number that occurs the most often. Now, because the measurements of your cherries were really similar, a mode exists. Sometimes though, you don't have a mode because not all of your numbers are all different. None of them are identical to each other. So if no mode exists, it will say NA, it'll say this. If no mode exists, okay, which is fine. If a mode doesn't exist, it doesn't exist. So, okay. Then down here, this is variance and this is standard deviation. What do variance and standard deviation represent?
the distribution in terms of like, from this, like the average value?
Spread. Kind of like the spread away. How big is the spread of the data points away from the mean, from the central tendency? Okay, good. All right, so variance is a similar one. But I like standard deviation better, so that's what we're gonna do. Okay, so this is something that you're gonna report in your lab report, okay? And so all you're gonna have to do, what should happen is all you're gonna have to do is when you put your data in here, these are gonna populate for you. So it's just gonna be as simple as a copy and paste. And look, here it is, it's pretty. Okay. Let's talk about our performance curve graph. All right, so I'm gonna zoom back out because go away, toolbar thingy. Hold please. I'm gonna move you over there for a minute. Okay, view. Let's go back to 100 just so that we can see the graph. So it just put one in because I had one before and I left it there. But what I'm gonna do is I'm gonna put it over here so we can't see it. So, because I'm gonna teach you how to make one. Okay, so here's how you make a graph. First of all, this is a line graph. How do we know when we want to make a line graph versus a bar graph? So line graph is when we're looking at like something over time, or we're looking at a trend or something like that, which is what we're doing. We're looking at a trend, what happens to the mean as we add more data points, right? So it's a line graph, okay? And so typically the way that I do these is I usually highlight. So it was pre-highlighted for this graph, but I'm just gonna do it from whatever, okay? So I'm gonna highlight my whole. You're not gonna, right? Yours is only gonna be your data, so it's gonna be smaller. But you highlight it with the, you see how the variable is also highlighted, okay? And then what you do is you go to insert a chart. They like to call them charts instead of graphs because Excel is made for serious business people, not for scientists, but that's fine. So what kind of data are we doing? A line or an area chart? Are we doing a bar chart? We're actually doing a line, and then you can pick what kind you want. I personally hate like having little blobs on everything because it's hard to see. And don't do fancy crap just for the sake of it. Be like, oh, I'll make it 3D. Like the point of these is that they are clear and they tell the message that you're trying to tell. So don't make them fancy just because you can. You are not fifth graders who are like, playing with PowerPoint for the first time. Okay. Dang it. Okay. So I'm just going to pick this first one. All right. So, oh, look, it made me a little chart. And it filled in some information for me already. It filled in it named them sun and shade. Yes, I can. Oh, wait, I'm going to do custom. Hold, please. I'm going to do custom so we can zoom in, but not all the way. Right. So it did that. Okay. But then, I can change this. So what is my title going to be of my graph?
Do you want to do like y-axis or just like?
Oh, okay. So in this particular case, I already oriented the Excel file appropriately so that our X and Y would be right. You're welcome. Because, right, our independent variable is this. Our dependent variable is this, yeah? Okay, so I already did it the right way. And I set up the other things the right way too, so you don't have to think that hard about it, but it's good to think about. Okay, so what should our title be for our graph? Well, it's a performance curve, so we want to say that for sure. So here's the thing about performance curves. This would never be something that you would like publish or share in a lab report. This is just for your own edification, right? So you want to put a title on it so that you remember what you made, but it's not like official. You're not going to put these in your lab report. Okay. So I just want to put in enough so that I can remember what it is. And so there's my title, there's my sun versus shade. And then if you want to add anything else, I'm going to move that out of the way. If you want to add anything else, what you do, I don't know how to do this if you have a Mac because Macs are whack. If you have a PC, you right click on just some empty spot of the graph. And then it lets you do all kinds of things. So, ooh, I need legends. Ooh, I need a vertical axis. So I can mess with my values. I don't want to do that. I want a label. Major grid lines. I don't care. I don't want a legend. I want category area. Is that what I want? No, hold please. Oh, I use the plus. My bad. So the little plus is where I add chart elements. It's a good thing that I'm recording this too, because I never remember all this stuff until I'm doing it. And then I'm like, I forgot how to do that. So I want chart titles. I want to add chart titles. I don't want to add data labels because that's dumb. I don't want to add any of the rest. I don't want to add a trend line because it's already aligned. So yeah, so just data. So axis titles. And then you can even be like, I only want one. I don't want one. I don't want that one. Okay. So now what am I going to call this? Okay, which we could just let's make it easy on ourselves, y'all. Okay, now it's kind of hard to type on these because you're like, how do I delete this? And you got to go up, and you got to go up, and then anyway. Okay, so what's that?
Cherry length.
So just units. We already know it's cherry length data, but so what is it? It's length. Wait. But is it just raw length?
Average row?
So it's, how about it's cumulative mean?
Oh,
So cumulative mean length. Yeah? Yeah? Okay, good. Beautiful. Nice work, fam. Okay, now let's just for shiggles. Well, before we do that, so what do we think? You can make this bigger, by the way, just by grabbing the corner and pulling it.
Is that possible, like, to zoom into the graph?
the first one?
Yeah,
What do you mean?
like, what if I wanted to say, like, what the lines mean, which I already have?
Oh, so then you just, you mean like cut it so that you're only looking at that part? You could, but we're not doing that right now. But you could, yes. Okay, so anywho, I made this a weird shape now. Let's get it back under control. I made it all weird. Let's make it look more normal. That's still weird looking. That's a little better. Okay, so what do you think? Did we collect enough data?
Yeah. We did pretty
At
good.
what point do you think we collected enough data?
Yeah, like the layer 20, yeah.
Like, and remember, the two lines don't have to be close to each other necessarily. It's just each line has to be pretty straight. Yeah. So both of those lines become pretty straight right around, I don't know, 17, 18. Okay. When you do your performance curve, it's only going to be for 10. Yeah. So your sample size might be too small. But once again, that's by design because we're learning. And so that would just be something you would mention in your lab report is our results are suspicious because our performance curve, blah, 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 blah.
So even if my phone is clear, you'll be too much for all time.
Yes.
Oh.
Yes. Okay. All right. So are we cool? All right. Let me go look at now let's look at my other one so that we can see so I changed so I like wrote it slightly different because I changed my mind on what I wanted to say, but same thing. Yeah. Cool. Okay. So for yours, I think I might even have it set up so that, yeah, I do. When you put in your data, it's automatically going to even make the chart for you. I'm a giver. I give till it hurts, you guys, till it hurts. Okay. So all you have to do is put in your data. And then I think you might have to do the performance curve yourself. You might have to like actually do the typing with the dollar signs and right. So you're gonna have to do that part. But once you do that part, I think all the rest of this will work for you. Okay. Then there's another little spot that I made here. And this is where we're going to do our data, where we're going to do, so the reason I made this page, this tab, is so that this is where you're going to have tables and graphs to make them look pretty for your lab report. So that, remember last time how it was just copy and paste it as a picture? Yeah. So we'll do that again. Okay. So here's what I'm going to do. I'm going to copy and paste my stuff so I can show you how to do it. So I'm copying So I'm highlighting, I'm copying. And I'm pasting. And remember, when something has been using an equation elsewhere, you have to paste as values, right? Otherwise it's going to take those equations over there and it's going to jack it all up. Okay. So I paste values. Cool. So now now this table is ready to go for my lab report, which I'm going to write. Okay. And then I want to make a graph that I'm going to put in my lab report. And the graph that I want to make now is I want to make a graph of the comparing, right? To try to answer our question. I want to make a graph where I'm looking at the mean length of the cherries on the sunny side and the shady side. What kind of graph am I making? A bar graph, because I'm doing a comparison. Yeah. Okay. And so here's my cute little graph. Right. And so what I'm going to do is this graph is linked to this area right here already. So all I'm doing is I'm taking I'm going to copy, and I'm going to paste, and then I'm going to do same thing with my standard deviation. Copy, paste. Whoa, look at that. Okay, so the way to do the whiskers, they are a massive pain in the butt to do. So I built this so that as long as you don't screw up any of my stuff, you can just plop it in and it'll do it for you, so that all you have to do is interpret. Okay, I will probably at some point make another video of how to put on whiskers on your own data, for future lab reports. But for this one, I did the whiskers for you. Okay, so maybe we need to take a minute to talk about how to interpret this. They're very similar. Not only the means, which is the bar, right? But then also the whiskers overlap quite a bit. Yeah. Yeah. So what might that indicate? Maybe, right? So right. So early analysis indicates that we probably have to accept our null hypothesis, but we're going to do actual stats. We're not just going to, let that graph tell us. Yeah. Okay. So now, oh baby, let's open up StatCat. So exciting. Stat Kitty. Where are you, Stat Kitty? I love it. Okay. So we there are things we have to do. Yes. What do we have to do?
Oh wait, no, the test is for the
Before we can do our actual statistical analysis, we have to know if we're doing parametric or non-parametric, right? Which means we have to test for normality. Blah, blah, blah. Right? So we can either use the button or we can use the tab to test for normality, right? Okay. So, oh, look at that. How do I do that? All right, well, what I'm going to do is I'm going to do all the raw data. You guys are just going to be doing 10 and 10, right? But I'm going to highlight. Oh, wait, no, don't get crazy, Sarah. Okay, I'm going to highlight. I'm going to copy. And then I'm going to go back to StatCat. I'm going to plop that in here. Okay, and then look, it tells me right here, distribution is normal. So I don't have to read any of the numbers or any of the crap up here. I just go, it tells me distribution is normal. Okay, and then I can delete that and I can go check the other. So that was for my sunny. So let's check my shady just to be on the safe side. So once again, I'm just highlighting this whole column, and you guys, you're just going to be highlighting 10 things on each side, not 60. Huh?
Should we know that in our lab?
No, what in your lab books? I mean, yeah. I generally write stuff down as I'm doing it, so that I just on scratch paper, so that then when I write my lab report, I can remember what I did and what the answers were. So you could write it in your field notebook, or you could just, write it down, and then when you do your lab report, it'll come up, right? So copy. All right. So let's go back to Stat Kitty. Okay. Oh, snap. Okay, wait, hold on. Ignore that. We're only focusing on where it tells us what to do. Oh yeah, look at that. Not normal. So what does that mean? So I can't use my parametric test. Okay, so I have an interesting idea though. I'm gonna try something else. I'm gonna see what happens if I do both of them all at once. So I'm gonna highlight this too. So that was my shade. Here's my sunny. I'm just curious. Back to Stat Kitty. It's like, nope, still not normal. Dude. Okay, so what does that mean? So since it is not normally distributed, that means that I have to use the non-parametric test. Okay, so then, and I, by the way, this is all just, I'm gonna do the whole class data and write a lab report and share it with you all after you do your own on just your data. Okay. So then what do we do? Okay, so it's not parametric, so we have to go with the non-parametric side. And we're comparing sample to sample, right? Okay. And we're doing one comparison. We're not comparing more than two groups. So we're comparing one group with another group. So that's a single comparison. Okay. So we're doing that. And then we're, so samples related, this means paired or unpaired. So, you guys are not, and I'm recording this, but it's not even going to be able to see it, but that's okay. It doesn't matter. Paired or unpaired, and we picked non-paired, right? What would it look like if we were doing paired?
Does that mean the data are related to each other?
That the two sides are related to each other. So like, let's say that we wanted to know something about like length and width. And so we were measuring those two attributes on one fruit. That would be paired data. Yeah. But this is not paired. These are just individual cherries. Yeah. So you can't read this because it's blurry, but it says a rank sum U test. Okay. What the heck is that? So back to this, right? So if your data is non-parametric, you choose the Mann-Whitney U. Okay, so let's go back real quick to Stat Kitty. Where are you, Stat Kitty? Okay, so we are doing a 2-sample independent test, right? Because we have 2 samples. They're independent of one another. And then it has group 1, group 2. Hey, let me just copy my stuff again. So once again, I'm just copying and pasting it over there. You don't have to type. Once you get it typed in once, you don't have to type anything by hand, you know? Let's open up Stat Kitty, plop that in here.
If one's parametric, the other's not parametric.
Then it's not parametric. They would both have to be normal for it to be parametric. Yeah? Okay. Now, oh my gosh, that's a lot of crap. Oh, we need to explain all of this. Okay. So because our data is non-parametric, is it going to let me do that? It's not. Okay, but I'll point. So because we're non-parametric, what I'm going to be reporting is I'm going to be reporting the U value, which is this. And then I'm going to be reporting a P value. We'll talk about what this whole 2-tailed, 1-tailed thing means again. So U tells us that's the statistic that is calculated. We always report it. We don't care what it means in this class. Okay. All right. But P, you know what P is? What is P? Alpha probability. And what does P tell you? Whether or not you can reject your null hypothesis. Okay. Now, this is P 2-tailed, P 1-tailed. What does that mean? I can zoom in. So a 1-tailed hypothesis is basically asking if your hypothesis goes in a single direction, whereas 2-tailed means it goes in either direction. Okay, so is our hypothesis, our alternate hypothesis, is it directional?
Yes.
Yes, because we assumed that the ones in the sun would be longer. What would be an example of a two-tailed hypothesis? That they're different, but we didn't have an opinion about which way. Does that make sense? So if we're just asking, is this pile of data different from this pile of data, but we don't have a particular reason to think that one is more or less or whatever than the other, then that's a two-tailed. But since we are under the impression that more sun probably means bigger fruit, that's a one-tailed. Okay, so what is my P one-tailed? So my P one-tailed, right? And so I'm writing down what my U was. You guys are watching me do this. I'm writing it down because I'm going to put it in my lab report. Okay. And then my P, and I chose the one-tailed because of the type of hypothesis that we did. And let's see if I can write it correctly. 0.03234. Now you're not writing this down because you're not doing a lab report on the whole class data. You're doing your lab report on just yours. Okay. So that's what you would do if you get non-parametric. But what if you're doing a parametric test? Then what? How do you know? First of all, how do you know if you're doing parametric? Based on the results of your test for normality. So if your data is normally distributed, you had better do a parametric test because they're better. Yes? So we're just going to pretend for funsies. We know that this data, that the whole class data is non-parametric. But let's just pretend that it is so I can walk you through what all of this crap is. Okay? So the first thing we got to look at when we're doing a t-test. So the non-parametric version is called a Mann-Whitney U test. That's the non-parametric test. The better test to do, if you can, if you have parametric data, is to do the t-test. Okay? But there's lots of options for t-test. So we got to figure out which one we want to do. Okay? And so here's how we figure that out. Right? So I'm going back to this PowerPoint for just a second. So the first thing we do is we have to figure out the test for homoskedasticity. That's the best word ever. Okay. So we're going to just in our brains, if the P is greater than 0.05, that means that the variances are equal, because that's what homoskedasticity is about. It's about, are the variances equal or not? Okay. So in this case, if P is greater than 0.05, they're equal. Okay. Because I said it on the slide. Because I told you so. Okay. So let's go look. Is our P greater than 0.05? Here are the P's. Well, it doesn't even matter because look at, they're both so far below 0.05 because this is when we're orders of, we're scientific notation crap, right? Yeah. So they're both so far below 0.05 that means, if I go back and look at this again, if it's below 0.05, that means no, the variances are not equal. Okay, cool. Check. Not equal. So that means I'm not going to use this data right here or this information right here. I'm going to use this information right here. So what am I going to report? I'm going to report my T. I'm going to report my degrees of freedom. And then which P am I choosing?
One-tailed.
I'm choosing the one-tailed because our hypothesis was in a single direction. Yeah. So yes. So the tail is about, do we think that there's a difference in only one direction, or is the difference in potentially both directions? So in this case, what we're asking about is length. And so what we're saying is we have a preconceived notion that one of the data sets will be longer than the other one, but not vice versa. So that's why it's one-tailed. If we were just asking a question of, is this data set different from this data set, but we don't have any opinion about which way it would go, that would be two-tailed. Does that make sense? Okay, so our hypothesis is totally a one-tailed hypothesis. It's, we think sun is going to be longer than shade. Okay, good. I'm glad we got that. Okay, so we're picking the one-tailed, and what is it? It's 0.00696. What does that mean?
Oh.
I'm waiting.
Reject the null hypothesis.
We can reject our null hypothesis. So we can accept our alternate hypothesis. We can reject our null. Okay. Now, in reality, because our data was not normally distributed, these are not as accurate as this is, but it still gets us the same conclusion, right? So cool, whatever, it's fine. All right. So then what we're going to do, so that's all we're going to use Stat Kitty for. I'm not going to like close it. I'm not going to make it go away. I'm just going to close it. So, there's a place up here for you to type that in to make a pretty little table. Okay. So since I did a Mann-Whitney U, right, I'm going to write Mann-Whitney U. And because Mann-Whitney doesn't care about whether or not the variances are equal, I don't need that there. So if you do a t-test, you would write t-test results, and then you would write if the variances were equal or not. Okay?
Can you do that again and like, yeah, I'm sorry.
That's okay.
To get to the t-test, is that in the tab or are we doing the same?
No, it was the same tab, right? We just did that. It's it right. It's just, well, it's above it. The U was below the T. Yeah. So it's the same tab. And by the way, all of the directions for this are in this PowerPoint. The PowerPoint that I showed at the beginning that was meaningless because you didn't know what we were doing yet, right? It's the stuff is in here. So if you find yourself when you're doing your lab report being like, oh crap, what do I do next? It's probably in here. Okay. And if it's not, you know, you can always ask me. Be like, yo, Sarah, your PowerPoint sucks. Okay. So where were we? Oh yeah, I was making this a little bit bigger for Amber. Okay. So I wrote in where it says table 3, I changed it to Mann-Whitney U results because that's the kind of test that I did. If you had done a t-test, you would right here, you would say t-test results. And then you would say like what kind, like was it equal variances or unequal variances? Right? Which was also which one of these we pick based on that. Yeah. Okay. So all of that you wrote down on your scratch paper or in your field notebook. I don't care. Right. As you were doing it. Yeah.
Oh, I see where, okay, now the test for me is the bottom.
Right. So the test for homoskedasticity tells us which, if we have equal variances or unequal variances. Right. And then we know it's one-tailed. So if you're using a t-test, you need to pay attention to this stuff. If you can't do a t-test because it's non-parametric, it's actually kind of easier because you don't have to deal with the homoskedasticity issue.
So if there's a difference in the variances, then
You just pick this. Wait, excuse me.
how do you know if it's unequal? That's where
Okay, that was back here. So if the P is greater than 0.05 for the test for homoskedasticity, just that one, then you pick that. If the P value is lower than 0.05, then they're not equal. Just for the test of homoskedasticity, right? So the reason we said not equal is because these are both super low. So we picked the unequal variances. Yes? Okay, cool. Good. So then only if it's t-test, because we don't care what the variances are if we're doing a non-parametric test. Okay. All right. So then I made this little table so we can put in our data. So I did a U. So you would write T here if you did a T. I'm going to write U because I did a U. And I don't need to do degrees of freedom because I'm doing a U. So I would take this out completely and move this stuff up. Because I don't worry about degrees of freedom when you're doing a U. Okay. But if you're doing a t-test, you would report your degrees of freedom. So my U value that I wrote down on scratch paper, because I was, oh God, come on. Why are you not, oh, my number lock button. I hate that. There we go. Okay. And then what was my P? My P was 0.03234. And can I reject my null? Or do I have to write accept my null? Because it's below 0.05, I can reject my null. Yeah. So I'm going to leave that there. Right. And then once I have all of this stuff made, then I can just copy and paste this and put it directly in my lab report.
Was all this data from both the sun and the shade data combined, or was it?
Well, because that's what we're doing is we're comparing them with each other. So they're not combined. We're comparing them. No. No, you're doing, those are the two columns. Sun, shade. Yeah, you're comparing them. If you try to just fill this in with just one set of data, I don't know what it would do, but it wouldn't do anything good. Okay. All right. All right. Yeah, cool. Good. Yeah. Any other questions? Okay. I think I'm gonna stop recording. Just because we'll